everybody, let's try this problem. So we have a bar, so I'm going to draw the free body diagram. And let me label these. I'll call this pin B and roller C. Okay, and then I'll pick coordinates like this. Okay, so there's a reaction at the pin at B, which I will decompose. There's a reaction at the roller at C, over here. And there's a distributed load. So I will represent the distributed load as discrete forces. It looks like kind of a rectangle with a triangle and another triangle. Okay, so for the rectangle, let's see, it's 208 feet over here. So the area of the rectangle is 1600. So that's the magnitude of the force. And the location is at the centroid of the rectangle, so 4 feet. Okay, now for this triangle, the area is 1/2 base times height. And then, so here to here is 300, here to here is 200, so here to here has to be 100. Right, so for the triangle, the area is 400. And then the location of the centroid is 2/3 of the way over this way, 2/3 of 8 feet. Okay, I'm just going to leave it like that. All right, and now for this triangle, the area is 1/2 base times height. Okay, so that's 600. And at the centroid of the shape, which is 2/3 of the way over this way, 2/3 of 4 feet. Okay, I'll just leave it like that. All right, so now we got the free body diagram with the distributed load represented as discrete forces. So now you just solve for the reactions at the supports. So x direction, bx, y direction, by, plus c, minus 1600, minus 400, minus 600. Okay, some torque about wherever we want, let's say over here. Okay, so there's torque from this, so that's negative 4 feet, 1600 pounds. There's torque from this, minus 16 over 3, 400 pounds. There's torque from this, so let's see, the entire bar is 12 feet, so minus 12 feet, the difference 12 minus this much, right? Times 600 pounds. And then there's torque from C, which is in the positive direction, plus 8 feet times C equals 0. Okay, you get everything? Yes. Okay, and then let me point out the unknowns. Okay, so then that means we can solve this for C, plug it in here, then you have by, Vx is 0. Okay, so at this point, we know all three of these. So now it's time to section through point A. But now here's the thing. Point A is 6 feet over, like somewhere over here. We don't cut this representation. This would not be okay. You have to go back to the original, and then you cut the section over here. That's the way to do it. Not like this. Not with this representation. That's not okay. Okay, so we're done with this. We leave it behind. Now we're back here. Now we cut a section right here through A. That leaves us with this left section and the right section. Okay, and then let's see. There's the distributed load like this. Okay, and then kind of like that on the right section. Okay. And then let me fill in the rest of it. So there's the pin at B, roller at C, and then all the internal forces and moments, right? Axial force, shear, bending moment. Okay, now which of these representations looks easier to analyze? They both look like a mess, for sure. So I'm not sure which is better. Maybe this one? So totally up to you. Okay, but let's take a look at this. How much is this right here? Okay, so here is, it's 200 over here, 200 pounds per foot. How much is it over here? What is the slope of this? Okay, it looks originally, right? It was this, it's 200 over here, 100 over here, right? Because here to here is 300. I'm looking at this entire thing right here. So what is the slope? Let me look one more time. It was 8 feet across this way. Okay, so what's the slope of this? Rise over run. The slope is 100 over 8. And then you see how there's this y-intercept like this? Plus 200. So that's the function. But then if we chop it at 6 feet, right over here, how high is this right here? So it's the slope, 100 over 8 times 6 feet, right? So then that's it. Oh, and then I forgot, plus the 200 over here. Right, so this number is this right here. Okay. So let's keep going forward. Let's analyze this section right here. So now that I cut it over here, now it's okay to represent this distributed load as a discrete force. And again, it looks like a rectangle and a triangle. So the rectangle, again, this is 6 feet over here. The rectangle is 200 times 6. Okay, so that's the area of the rectangle. The location is at the centroid of the rectangle. Okay, now this triangle, what is the area of the triangle? I shouldn't have erased what I just had there. So it looked like this. Right, again, right, this is 200, this is 100, but then we chopped it right here. Here to here is 8 feet. Here to here is 6 feet. What was the slope? 100 over 8. So here to here is 100 over 8 times 6. Okay, so what's the area of the shape? 1/2 base times height. Okay, that's the area of the triangle. So let's break down. So that's 1200. 6 over 2 is 3, right? So 1800 over 8. I'll just leave 1800 over 8. Okay. And then where is this force? At the centroid of the triangle. So that is 2/3 of the way over this way. Like that. Okay. So there's the distributed load represented as discrete forces for this section. Okay, I'm gonna just get rid of this. All right, and then the rest of it, Bx, By, and all the internal stuff. Okay, so now that we have this, you can solve for the 3 unknowns. Right, x direction, y direction, let's see, minus v, minus 1200, minus this. That's it. Okay, and then some torque about anywhere we want. How about here, the right side? Just for a change, how about if we sum torque about over here, about point B? Okay, so there's torque from this, so minus 3 feet times 1200 pounds. There's torque from this, minus 4 feet times this. And then there's torque from V, minus 6 feet times V, and the bending moment plus. Okay, and then let me point out the unknowns. Oh no, we know that already. Oh, I forgot to write P over here. Plus. Okay, right, because there's this and this. Okay, so unknown, what else? Unknown. Okay, so here, solve for P, solve for V, take that value, plug it in here, solve for M. Then you got the shear, axial force, bending moment. Okay, and then again, you could have also analyzed the other section, and then you would get the exact same answer. So either way. Okay, so keep on practicing. I'll see you in the next video.